Hello, my dear students. Hello, viewers. Hello, future electrical engineers. So, let's proceed to another topic. So, this is equivalent circuit per phase of an alternator. Okay, so the last subject that we have is we tackle the circuit tree. No? So, circuit tree talks about the balance loads, three-phase balance loads, and as well as the three-phase unbalanced load. Okay, so this time we are going to tackle the source that supplied, no, that being supplied to the balanced load or unbalanced load. Okay, so as we can see here, so this is the um, armature of the alternator. Okay, so this is not the rotor, but this is the armature, which is the stationary part of the alternator. Okay, so this is winding number one. So it composed of many coils. It is not only, no, it is not only one, but composed of many conductors connected in series, so that the voltage will be summed up, and then um, will arrive with the specified or designed voltage output. Okay, so this is the phase, no, phase winding. Okay, phase number winding number one, phase winding number two, and phase winding number three. So as the rotor rotates, no, by the use of prime mover, okay, and then the rotor rotates also since it is coupled with the shafting, which is naana dito ang imuhang rotor, no, and the rotor as it rotates mo generate po siya of DC supply, so that it will supply to the field windings of your rotor. Okay, as it rotates, it supplies magnetic field, no, of the alternator, no? So that magnetic field rotates as the rotor rotates also, enables the winding of the armature winding enables it to cut, no? As it rotates, makaagi siya wire, and then that wire cuts accidentally the magnetic field, the magnetic flux, and then that causes the alternator to induce EMF. No? Okay? So, as representation, okay, so as it rotates, no, magnetic flux will pass here, and this coil induce an EMF, no, as well as this one and another this one, no. Okay, so the generated EMF is delivered, no, to the terminal of the alternator. Ano? Okay, so no, be sure to remember to um, what we call take note, no, the configuration of your alternator. It might be connected in delta, might be connected in Y, no? And it might be a three wire Y configuration, or four wire delta Y configuration. Okay, so it is supplied to the three-phase balance load, no? Three-phase balance load. So take note that if the configuration is Y, your phase voltage generated, no? O mo to diri kani siya, kaning formula, that is the phase voltage, no? This one. Take note that this is phase voltage, not the line to line voltage, no? So EL, if you are going to solve for EL in Y configuration, remember that EL is equal to the square root of 3 times EP. If you are asked to find what is the line-to-line voltage of the Y configuration alternator, so given that, given the third wave phase, the KP, the KD, the frequency, and the flux per pole, so therefore you can solve for the induced EMF per phase, and then that is not the line to line, but that is a per phase. So you need to multiply it by square root of 3 so that you can have a line to line voltage. Okay? So Y connected, that is Y connected alternator. Now, the equivalent circuit per phase is this one. Okay? So, as I've said, the field windings is supplied by a DC generator, DC source. This one. So, it is controlled by depende, no, rheostat or whatever that controls the amount of current that flows in the file winding, so that you can um, control the amount of flux, no, that will be delivered, no, to the winding, no. Okay, so EP, this one, EP is, okay, we have RP here, we have GXP, okay, we have IP here, we have the load, okay, and this is your BP, no, the voltage of the load received by the load. So RP here, since it is coil, no, it has a resistance, no, as it turns and mini turns, so the resistance also will goes higher, no, and since it is coil, so therefore that is inductor, no. Okay, so GXP, that is your inductive reactance. Okay, due to the winding. So therefore, you will have this formula. Okay, you will have this formula. A EP at an angle of you want this one is equal to BP at an angle of 0. So this is our reference angle. Okay, reference angle. And plus IP at an angle of plus minus theta, uh, multiplied by the impedance of the coil. Okay? Multiplied by the impedance of the coil. Okay, so this is our formula, no? Balik ko na ko. EP at an angle of, okay, this is considered as the power angle. Okay? Power angle. Yes, equal to BP at an angle of 0. So this is our reference angle plus IP. Okay, so this is IP. It might be lagging or leading, no? So, lagging or leading. Kung leading ang atong power factor, so positive. Okay, lagging gani, so negative. So bear in mind, lagging negative to siya. Lagging negative. Okay? So next is, okay, multiplied by the circuit impedance. Okay? So that is per phase, huh? This is per phase. That is why the subscript is P. No? Okay? So let's have an example so that sabtan pag yun nato. Okay, so a three-phase 318.75 kVA 2,300 volts alternator has an armature resistance of 0.35 ohm per phase and a synchronous reactance of 1.2 ohm per phase. determine the no-load line-to-line generated voltage at full load kVA, 0.8 power factor lagging, and rated voltage. So, hantag pangitao, no? Okay? So, this time, okay, hindi remind ta ani. No? Camping lang kita sa pag-solve, no? Careful lang kita para di ta masayo. Okay, so let's identify what are the given first. Okay? What are the given? Three phase, or that is number of phase. 318.75 kVA, what is that? That is your rated, no? Mo ni ang imo ang nasa nameplate. So imo ang alternator, no? 318.75 is rated na nimo. And then you have okay, kani mo ni imo ang naagya po sa nameplate, no? 2,300 volts alternator has an armature, so obviously this is your RP, and you have a synchronous reactance of 1.2, so this is your XP. Determine the no load. Okay, so no load line to line voltage, at full load kVA, so full load, so hurot na siya. Then, we have 0.8 power factor lagging. So, meaning we're going to use negative here. And the rated voltage. Okay, rated voltage is BP. Okay, now, how to solve this one? So, start with solving for IP. No? So, to solve for IP, remember this formula. No? This R is equal to square root of 3 IP o IL VL. Okay? So since we assume that this problem is wala i-state din, no? But always assume that this is Y configuration, so therefore IL is equal to IP. No? Is equal to IP. Okay? So, now, you can solve for IP, no? So, IP is equal to IL na siya. So, IP is equal to ESR divided by square root of 3 VL. Okay? Then, this time, where can we found VL? Asa may VL doon? Ano siya? Asa man natin makita in the problem. Okay? So, to find VL, so, ano na ipakita itong VL? Remember that these given are at full load, no? Full load na siya. So, remember that the alternator, once fully loaded, the output of the alternator voltage, no, in terms of voltage, will decrease, no, at a certain amount, no. So, like for example, this 2,000. Okay, next is substitute, no, substitute. But before that one, we are going to solve what is the angle, no, theta. So let's remember that cosine theta is equal to PF. Since PF is equal to 0.8 and cosine theta, therefore cosine theta is equal to 0.8. No? Where that is equal to, okay, our cosine of 0.8 is 36.87 degrees. No? So that is your theta. And since that is lagging, so meaning to say we're going to use negative, no, from this. So negative theta. So let's substitute, no? Let's substitute what are the known, no? What have been solved. No? So BP So BP, okay, so from here, that is your VL, no? That is BL. So therefore, BP is BL. So that is since BL is equal to 2000, no, square root of 3 BP. So BP is equal to 2,300. BP is equal to 2,300 divide square root of 3. No? Okay? So, proceed ta. So, meaning to say, BP is equal to 2,300 divide square root of 3 plus IP is equal to 80, no? 80 at angle of negative 36.87, okay, degrees times, okay, what is RP? So 0.35, so 0.35, okay, so plus J 1.2, no, 1.2 ohms, okay. So simplify that one, so your EP for the induced MF per phase is equal to how much? Okay, so check your answer. That is 1,409.18. Okay, that is at an angle of 2.4. Okay, degrees. Right? No? So this is the angle or the gap, no? Power angle is the gap between EP and BP, no? EP and BP. Okay, so EP is from the alternator side and then BP is from the load side, no? So since ang atong VP is the reference, for example, this is your VP. Okay, so this is BP, so this is your EP, no? AP. So this is approximately 2.4 degrees. Okay? So that is the gap, no? The gap. Okay? Right. Okay, now, what is asking the problem is determine the no load line to line generated voltage at full load KVA. So how to solve this one? Since we have already the AP, which is equal to 100 1,409.18 angle 2 point at angle 2.4 degrees. Now, what is this? And what is this? Okay? So to differentiate the two, 2,300 volts alternator, this voltage is at full load. No? At full load, the voltage will drop. Okay? The voltage will drop. No? What will happen? So meaning, at full load na siya, this will be received by the what? Load terminal, no? Load terminal of your voltage, of your load, I mean. So remember, our load is also a three-phase, no? Like for example, three-phase Y configuration. Okay, so this is your VL. Okay, so this is your VL. Okay, so this is your VL also. So what will happen is that 2,300 when activated ang atong load, so mo ni siya ang atong VL, no? That is rated, no? At full load, no? When loaded. But but what if at no load siya? At no load siya. Okay? That is why isolve nato diri ang BP. BP which is equal to, okay, divided by VL divided by square root of 3. Okay? So this time, what is asked in the problem is determine the no load line to line voltage generated at full load KVA. So therefore, it is on the what? It is exclusive only to this one. No? Walay lambot diri napita, no? Walay lambot. Okay? So those VL ang atong gisolve kanina, okay. Yeah, to solve for BP. So that is for the load, no? Since at no I assume here I assume EL is equal to VL lately, that is because when loaded VL is equal to EL, no? So don't be confused, VL and VP is on the load side of the is on the load side, no? Sa load side ni siya nimo. Pero ang imong EL o EP, so that is your generator. So imo ang alternator side. Okay? I hope you understand. So therefore, what we're going to do is, since we have EP, EP which is equal to 1,409.18 angle 2.4. Okay, so 1,409. So therefore, your EL at no load, no? Kung ining specify din, no load siya, is equal to this one, okay, multiplied by square root of 3. Square root of 3. So, square root of 3 of EP. Or that is, multiply by this one, so your answer will be 2,440.77. That is your EL at no load. Okay? So, let's see, no? Tanawin to, 2,300 and 2,440.77 has a big difference nga naman. This time, this 2,300 is loaded, no? Fully loaded. On loads here. This one is no load. So therefore, we can say that there is a voltage regulation, no? Voltage regulation percentage, no? Percentage of voltage regulation happen. Kay pag load nimo sa imong generator, ni ubos man ang imuhang voltahe, no? Ubos man imong voltahe. Therefore, your EL is equal to 2,440. Okay? Right. Okay? So, that's all. Okay, that's it, no? So, that is how to solve for the induced EMF in alternator topic. Okay, so I hope you will apply these learnings that you have learned in this video to solve, no, for several problems which is related to the topic. Okay, God bless everyone. God bless future electrical engineers. Okay, so